Hello, my name is Thomas and I'm a PhD student in Lübeck, which is next to Hamburg in the northern part of Germany. And I'm interested in the mathematics of image computing, namely in medical applications. My last work was on brain images, and I do a lot more. So in your brain white matter, you have very complicated fiber structures, these neural axon fibers, which connect different parts of your brain, like for example, the part of your brain which is responsible for your speech understanding, and those parts which are responsible for associative stuff that your brain is doing. And it's just a very basic question to understand how exactly these axon fibers are connecting different parts of your brain. So this is not really with a specific medical application where you have patients that you treat with it or something, but you want to understand the brain. So in this particular work, I was concerned with the question of how to trace the fibers of neural axons in the brain, in the living brain. So we're not talking about like taking a brain from dead people or something, but really we can measure the fibers in your brain when you are alive. But this needs a lot of mathematical tools. Yeah, the mathematical challenge is that the kind of data that you have is not just like some kind of gray value. Like, I think most of the people have already seen brain images like CT images or MRI images, but they don't contain actually any information about the orientation of the fibers. But instead, they only contain like information about the density of the matter of the tissue or something. And if you want to have information about the orientation of fibers, then you are faced with a problem that your data is like ambiguous, because you will have in one point in space where you're doing a measurement, you might have several fibers crossing in that place, and you might have ambiguity about the orientation. And then again, orientation vectors are like three-dimensional things. That's not like a one-dimensional gray value or something. And you have to really be careful when designing mathematical models for how to cope with this, how to do denoising, how to say whether an image is of good quality or of bad quality and stuff like that. So what we do is we define a mathematical model which describes what our measurements actually can do, and we are then able to define or to model new frameworks that allow for denoising. So we are able to improve the quality of the data so that we can in the end reconstruct from them really fiber tractography, that's called. I have actually a background in the theory of partial differential equations, so that's actually something which has many applications in physics. But in this particular problem, I need I need several methods from partial differential equations, but more from the theory of calculus of variations, it's called, and that is the field where you minimize energy functionals, and because you are interested in certain minimizers which you know a priori, so before you already know that these minimizers will have certain properties that you are interested in. And this is more or less what I'm doing here also, yeah. I changed my field of interest at some point in my career, because after my master's, I thought up to now I haven't touched any applications of mathematics, and that was somehow unsatisfactory, because I felt so detached from the world somehow. I was always working with something what you would probably call pure mathematics, and now I thought there are not that many options which really make a difference in the world, and where I still can do really difficult and abstract mathematics. I wanted the combination that was important to me. But in imaging, image processing, that's really possible, actually. So you can really help the people. You can do medical research in a way. and still use really very complicated mathematical methods. I have nice mathematical moments all the time. Like it's not like it's constantly like this, but mathematics just works like this. You have a hard problem, and it's of course sometimes also frustrating. But it's like regularly every month or every few weeks or something, you have some moment where you see that your hard work really brought you somewhere, and that's really a nice feeling.